Hello, myself is Anil Kumar Sharma. I am from Sham Academy. Today I am here to give you a lecture on the topic differentiation. Let us recall what you have studied in your previous class. A function defined by, say, f dash x equal to limit h tends to 0 f of x plus h minus f of x divided by h. Wherever the limit exists is defined to be the derivative of f. Now the derivative of f is denoted by f dash x or d by dx of fx. Now suppose if I say the function is denoted by y equal to fx, so here I denote the derivative by dy by dx, or I can write here y dash or y1. So what is derivative? How you will define the derivative? Simply what I can say, if I am writing dy by dx, it means the derivative of y with respect to x. Suppose instead of dy by dx, I write dz by dx. Now what does it mean? It means the derivative of z with respect to x. So in this way, what I can define the derivative or differentiation, it is the process of finding the derivative of a function is called differentiation. So what I define, it is the process of finding the derivative of a function is called differentiation. Now we start how to find the derivative of functions. Before starting, I am here to give you the derivatives of certain standard functions. First, I am writing here the functions. Say fx equal to xn, sin x, cos x, sec x, tan x, cosec x and cot x. Now what is the derivative of all these standard functions? Now the derivative of xn, it is given by n into x n की power minus 1. Now what is the derivative of sin x? It is cos x. What is the derivative of cos x? It is minus sin x. Now what is the derivative of sec x? It is sec x and tan x. What is the derivative of tan x? It is sec square x. And what is the derivative of cos x? Minus cosec x cot x. And what is the derivative of cot x? It is, here I can write, it is minus cosec square x. So in this you will see the certain standard functions in which the derivative I have written. Now I am going to explain it a little bit more. Say if I am writing here, it is y equal to xn. Instead of xn, suppose it is multiplied by with some number. So now what will be the derivative? Simply it is dy by dx equal to k will remain at the same position multiplied by the derivative of x n, what I have already written here. So it is n x n minus 1. Now if I say it is like this, y equal to 1 upon x की power n. Now how I can define the derivative? Simply I have to keep into the numerator side. So what I will write? Y equal to x की power minus n. Now what will the derivative? I will write like this, dy by dx equal to minus n into x, now minus n minus 1. Now this again I can write into the denominator. So minus n divided by x, now this will become plus. So n plus 1. So whatever be the form of a function, I can differentiate it in a simple manner. Now this is the simple what we study, standard functions. Now I will start with the basic rules how to find the differentiation of various functions. So first let us start with the algebra of derivatives. So in algebra of derivative of functions, suppose I consider there are two functions. One is say fx and another function is gx. Now how I have to find the derivative of these two functions when I am adding these two functions, when I am taking difference of these two functions, when I am taking multiplication of these two functions, and when I am the quotient of these two functions. Now first I will start with say sum of two functions. Now I have to find the derivative of sum of two functions. Now here instead of fx I can write say it is u, and instead of gx I can write here it is v. Now I have to write the derivative of sum of two functions. Now first I will write the u plus v. Now I have to write d by dx, that is derivative of u plus v. So here I can write u plus v dash, and this is equal to du by dx plus dv by dx. Now second case I consider the difference of two functions. Difference of two functions. Now what will be the derivative of difference of two functions? Here instead of plus, now it will come minus u minus v. So d by dx of u minus v. So here I can write u minus v dash. This is equal to du by dx minus dv by dx. Now the third come the product of two functions. Product of two functions. So how we will find the derivative? Simply d by dx u v. Now here the rule apply that is known as product rule. Now what is the meaning of product rule? First we take the derivative of first function u dash and we write second function as it is. Now then we take the derivative of another function and write first function as it is. So what it becomes? It becomes the product rule. Now the fourth one is quotient of two functions. Now I will write here d by dx u by v. Now this is known as quotient rule. Now what? How to write this derivative? This first the derivative of u dash. Now the v is as it is minus derivative of v dash. This u as it is divided by the v square. So this is simple algebra of derivatives. When we are taking the sum of two functions, it is simply just the derivative of both functions and we are adding. In case of difference, only we are putting a minus sign and taking the derivative of both functions. But in product rule and in quotient, we have to remember the rules. What is the rule? First we take the differentiation of one, then multiply by other. Then we take the differentiation of other and multiply by the first one. And in quotient, you have to remember that first you have to take the derivative of numerator, then multiplied by the denominator function minus derivative of denominator multiplied by the first function divided by the v square. So all this now we will see with the help of an example. Now here I consider two functions, say u is equal to sin x and v is equal to cos x. Now first I will find the derivative in case of sum of two functions. Now how I will write? First d by dx of sin x plus cos x. What I will write here? D by dx of sin x plus d by dx of cos x. So what is the derivative of sin x? It is cos x. And what is the derivative of cos x? It is minus sin x. Now second, we see the derivative of difference of these two functions. So what I will write here? It is d by dx of sin x minus cos x. So this again it will become d by dx of sin x minus d by dx of cos x. So what is the derivative of sin x? It is the cos x. Now minus, what is the derivative of cos x? Minus sin x. So what it will become? Cos x plus sin x. Now the third, we will consider the d by dx of sin x into cos x. Now here we will apply the product rule. What is product rule? First the derivative of u. So I will write here d by dx of sin x into the second function as it is, cos x as it is, plus now the derivative of cos x, and this sin x is as it is. So what is the derivative of sin x? It is cos x into cos x plus, what is the derivative of cos x? It is minus sin x into sin x. So what it will become? Cos square x minus sin square x. So simply here what I can write, it is cos 2x. Now the fourth example is, it is the quotient. Now we will find the d by dx of sin x by cos x. Now how we will approach here? First you have to find the d by dx of sin x. Now this multiplied by the cos x. Now here it comes negative sign. Now what is the d by dx of cos x? And sin x will remain as it is, divided by what is the square of this denominator. So here what I can write? D by dx of sin x is cos x into cos x minus d by dx cos x is minus sin x into sin x. So what is this? Cos square x. Now cos square x plus sin square x divided by cos square x. So what this will become? Cos square x plus sin square is 1 divided by cos square x. It is nothing but sec square x. So it is the simple algebra of derivative of function, in which we have added two functions, difference of two functions, product and quotient. So this is simply we have seen. Now next we start with derivatives of, say, various functions. First I will consider composite function. In composite functions we use substitution method, or sometimes we say it is function of function. How we can say function of function, or it is a composite function? I take a simple example of, say, if y is equal to cos x square. Now what you will see here? You will see here there are two functions. How I can say two functions? One is x square and the other is cos. So if I put x square as a u or t, so this will become cos t, that is another function. So such type of functions in which there is two or more functions, we say these are the composite functions. Now how to differentiate this? So in this type of functions we differentiate it by putting or by substitution. So how? Let us start. Suppose I put this, and I have to keep in mind I will start from the end. So what is here? X square. So I will put here u equal to x square. Now the first function is u equal to x square, and the another function will become now y equal to cos u. Now what I have to find? I have to find the derivative of y. So I have to find here dy by dx. But I have put another function u here. So what I will write here? First I will write here derivative of u with respect to x, because here variable is x. So what it will become? It will become simply 2x. Now I have to differentiate this y with respect to u. This you have to keep remember. So this will become dy by du instead of dx. So what is the derivative of cos? It is minus sine. So here instead of x I will write u. So here I get du by dx and dy by du. Now I have to find dy by dx. So what I can write here, dy by dx can be simply write by dy by du dot du by dx. So here these du will be get cancel out. So here I can write dy by du is minus sine u dot 2x. So what it will become? It will become minus 2x sine u. Now you have to keep remember, you have to replace this u by what you have initially put x square. So this is minus 2x sine x square. Now this is the method of substitution. Now there is one alternative method in which we can directly do the derivative. What is that? That is known as chain rule. What is chain rule? In chain rule, we start the derivative from 1 till the end. So how we will proceed? We will proceed directly. Say if y is equal to cos x square, here I will write dy by dx equal to d by dx of cos x square. So first I am taking the derivative of cos. I am keeping this x square constant. So what I will write here, it is minus sine x square into, now I have to take the derivative of x square, d by dx of x square. So what it become? It become minus sine x square dot 2x. So here I can write minus 2x sine x square. So what you will find, the same thing you have find here. So this is the method of substitution or by chain rule. So a chain rule is the very simple rule. Here we can find the differentiation in a single step. Let us see one more example. Suppose I write here, say y equal to sine cos x square. Now what you are seeing here, here are three functions. How you can say? One is x square, another is cos x square, and the third one is sine. So how you will solve this? First we will see by substitution. So first we are putting here u equal to x square. Second we are putting v equal to cos u, and the third one will become y equal to sine v. Now as you see there are three functions, x square, cos u and sine v. Now we will start differentiating with respect to x. So first du by dx, so it will become 2x. Now here instead of x we have to differentiate with respect to u. So what I will write here, dv by du. What it become? Minus sine u. Now the third one is y equal to sine v. Now here I have to differentiate y with respect to v. So what I will write, dy by dv. What is become? Cos v. Now what I have to find? I have to find the dv by dx. Now how I can write dy by dx? I will start from this dy by dv dot dv by du dot du by dx. Here you will see this will get cancelled by this will get cancelled by this, and it will become dy by dx. So just I have to put the dv by dv, it is cos v, dv by du, it is minus sine u, and what is du by dx? It is 2x. So how I can write it? It will minus 2x cos v sine u. Now I have to put with the value of here. What I have put here? Values. So first it is minus 2x. Now cos v. What is v? V, it is cos u. Now what is it? It is sin v. So sin, it is u sin x square. Now I have to put again here the value of u. So it is minus 2x dot cos x square into sin x square. So this a little bit complicated and it is taking more time. So now I will show the same with the help of alternative method. So what here we have write, it is y equal to sin cos x square. Now first we see the derivative of this by substitution. Now I will do by the chain rule, that is alternative method. So here how we will proceed? We will proceed in a simple way. First we will take the derivative of this sin, keeping this as it is. Now what it will become? It will become cos of x square. Now we will take the derivative of this d by dx of cos x square. So this will become like this. Again it is minus sin of x square. Now I will take the derivative of this x square. So d by dx of x square. So this is cos x square minus sin x square into 2x. So here this can be written as minus 2x cos x square into sin x square. You will see both the answers are same, but this method is quite easy. So instead of substitution we use this method, alternate method known as chain rule, in which we can do step by step derivative. First we start from the first function, say sin. I have to take the derivative of this with respect to x, then I have to consider the next, and then I have to consider the last. So in this way, when we do the derivative step by step, we can do it very good and very quick way. Okay, now let us take some more example about the chain rule. Now here what we will do, we will directly solve this. Instead of using substitution method, we will directly solve this. Say, suppose I consider a function, say it is y equal to cos x cube dot sin square x power 5. Now here you will see, here it is, there are two functions. So here we will have to apply product rule plus chain rule. Why chain rule? Because there is x की power 3 into x की power 5. So first I will do straightly dy by dx of, so first I will apply here uv rule. What is uv rule? This is u, this is u. First derivative of u. So here I will write d by dx of cos x की cube into, now this will remain same, sin square x 5, now plus d by dx of sin square x 5 into, now cos x cube will remain same. So what is the derivative of cos x cube? It is, the derivative of cos is minus sin x cube. Now I have to keep remember this, I have also take the derivative of x3. So what I will write here, d by dx of x3 multiplied by this sin square x5. Now in the next step, what I have to take the derivative of sin square x5. This is, I have to just multiply. So when I am going to take the derivative of sin square x5, here I have to keep remember, first I have to take the derivative of this power. So first I will write 2 sin x5. Now I have to take the derivative of sin x5. Okay, here I have taken the derivative of this. So what is the derivative of this? This is this. Now I have to take the derivative of sin x 5. Then I will take the derivative of x to the power 5. Now this will be multiplied as it is. So now what I can write here, it is minus sin x3 into d by dx of x3 is what is 3x square into sin square x to the power 5 plus now 2 sin x5 into what is the derivative of sin cos x5 into d by dx of x5 multiplied by cos x cube. Now what here I can write minus sin x3 into 3x square dot sin square x5 plus 2 sin x5 dot cos x5 dot 4x4 because it is the derivative of x5 into cos x cube. So here the same can be rewritten like this, minus 3x square into sin x cube into sin square x5 plus what is this 4 into 8 into sin x to the power 5 into cos to the power 5 into cos x cube. So here you see this one is a little bit more complicated, but if you will start and do step by step, here we can solve this function. So up to now we see the composite functions which consist of two functions or three functions. Then we see the example of in which there is a both combination of product rule and chain rule. So this was all about the composite functions. Now we are going to take the derivative of another functions that are known as implicit functions. Now what is an implicit function? Now this I can simply explain by taking two examples. Say if I write like this, y minus x plus 5 equal to 0 and y plus sin xy plus x equal to 0. Now this one is 1. This. Now in these two examples you can see the first function in which you can easily find the value of y. What you can write instead of this, you can also write like this, y equal to say x minus 5. But if I want to find the value of y or I want to separate this, it is not possible in this. So such type of functions in which it is not easy to separate y, these are known as implicit functions, and this is nothing but explicit. So first you got the idea how to find whether the given function is explicit or implicit. The implicit function is one in which it is not easy to separate y. Now we will start how to find the derivative of such functions. Now you can see the derivative of this is very simple. How? Here I can write say dy by dx equal to d by dx of x minus 5. So what is it? D by dx of x minus d by dx of pi. So what the d by dx of x? It is 1 and it is 0. So dy by dx it is equal to 1. Now in this function y plus sin xy plus x, how I will find the derivative? Here I have to differentiate this function with respect to x in both sides. So I can write here differentiate this function both sides with respect to x. So how we will proceed? We will proceed like this, say d by dx plus d by dx of sin xy plus d by dx of x equal to 0. Now you will see dy by dx. Now what is the dy by dx of sin xy? Here we will write cos xy into d by dx of xy plus 1 equal to 0. Now this will become dy by dx plus cos xy into, what I will do here, I will put the UV rule. So in what UV rule say, the derivative of first function, what is the derivative of x? It is 1. Now y is as it is. Now plus, now the derivative of y, what is the derivative of y? It is dy by dx into x as it is. Now this is plus 1 equal to 0. Now dy by dx, now I have to multiply this with both. So y cos xy plus x into cos xy into dy by dx plus 1 equal to 0. Now what I will do, here is dy by dx, here is dy by dx. I will just take it common. Now dy by dx is common, 1 plus x cos x y plus 1 plus y cos xy equal to 0. Now what I will do, I will separate both these functions. This I will take here, it is minus 1 plus y cos x y. So now I have to find the dy by dx. Now what dy by dx? Dy by dx is minus 1 plus y cos x y divided by 1 plus x cos x y. So in such functions where you have to find the derivative, just you have to differentiate both sides. And by differentiating both sides, you have to consider all the rules. What is the rules? Whether we have studied, that is UV rule, U by V rule, chain rule, or whatever the standard functions which have the direct derivative. As I have started with, just like the derivative of tan x, x squares, derivative of cosec x, minus cosec x, cot x. So all these just you have to remember, and you have to remember standard functions plus the basic rules. Once these rules you have kept in your mind, then it will become very easy to solve any type of functions. तो अभी हमने जो स्टडी किया, अभी हमने दो फंक्शंस के डेरिवेटिव स्टडी किए. फर्स्ट द composite functions and the second one we see implicit functions. Now the third one is inverse trigonometric functions. Now we will see how to find the derivative of inverse functions. Suppose I consider a simple example. If the given function is, say, y equal to sine inverse x. Now I have to find the derivative of this. Now how to proceed? Here we have to take the derivative both sides. So what I will write here, differentiate both sides with respect to x. Now we get, how we will write, y, it is dy by dx equal to d by dx of sine inverse x. Now if you will see the sine inverse x, so I cannot write the direct formula here, so I have to find the derivative. So what I will do, first I will write from here y equal to sine inverse x, so x equal to sine y. Now it is easy to find the derivative. So here what I will write, here I will write x equal to sine y. Now I will take the derivative of this function. So this is very easy. Now what I have to write here, d by dx of x equal to d by dx of sine y. So what it will become, the derivative of x is 1 and derivative of sine is cos y into, now the derivative of y, this is dy by dx. So dy by dx is nothing but it is 1 upon cos y. Now what is cos y? Now here you can see x is sine y, or in terms of cos y I can write here cos, what is cos theta? It is equal to under root 1 minus sine square theta. So here this I can write under root 1 minus x square. So what is cos y? Cos y is nothing but 1 upon under root 1 minus x square. So here we find the derivative of sine inverse x. What is that? It is dy by dx equal to 1 upon under root 1 minus x square. In the same way, we can find the derivative of cos inverse. Let us take one more example. Say I have to find the derivative of y equal to tan inverse x. Now how we will proceed? We will proceed in the same manner. Here x is equal to tan y. Now again differentiating both sides with respect to x, we get d by dx of x equal to d by dx of tan y. Now what is the derivative of x? It is 1. What is the derivative of tan? It is sec square y into the derivative of y with respect to x. So here it becomes dy by dx equal to 1 upon sec square y. Now what is sec square y? Sec square theta is equal to 1 plus tan square theta. So 1 upon 1 plus tan square y. So what is tan y? It is x. So 1 plus x square. So this becomes dy by dx equal to 1 upon 1 plus x square. So here in trigonometric functions we see two examples. One is x equal to y equal to sine inverse x, and the other one is y equal to tan inverse x. So how we have solved? We have solved by putting in the tan form, say x equal to tan y or x equal to sine y. So this becomes easy to solve and taking differentiation both sides. By the same method we can also find the derivative of cos inverse x, cosec inverse x, cot inverse x and your sec inverse x. So this is very simple and you can do by yourself. Next we consider the topic that is exponentials and logarithmic functions. Now we will find the derivative of exponentials and logarithmic function. Now what is a exponential functions? You have right sometimes you have seen e की power x. What is e की power x? This e term stands for exponential. So such type of functions in which we use e and something raised to the power known as exponential functions. And what are the logarithmic functions? In which we use log. And whenever it is not mentioned, you have to keep remember the base is always e. Now before finding the derivative, we also know some formulas for logarithm. What are that? There are few formulas. What is that? One is if log to the base e m की power n, if it is like this, so this is written as n log to the base e m. Now if there are two functions log m minus log n, both have base e, how we can write this? This can be written as log base m by n. And suppose if it is like this log e to the base m plus log e to the base n, here we can write it is like this log e m n. So considering these formulas, it is becomes easy to find the derivative. So first I will see what is the derivative of ex. Suppose if I write here y equal to ex, then the dy by dx of ex is same. It will remain the same ex. Now if I write y equal to log x, now what is the derivative of this? Dy by dx, it becomes 1 by x. So you will see these two are very simple and it is easy to find the derivative. Now if this becomes somewhat typical, then we use the logarithmic functions. How? Say if a logarithmic function is like this, y equal to x की power x. Now how we will proceed? Here we have to find the derivative. So first I will take logarithm taking log both sides, we get log y equal to, here we will apply the property of log, that is this, n will come in front, so here it is x, so here I will write x log x. Now I will differentiate this. Now it will become easy to differentiate this. Now differentiating both sides with respect to x, we get, now what is the differentiation of log? It is 1 by x, so here it is y, so I will write 1 by y dot. Now the differentiation of y with respect to x, so I will write dy by dx. Now what I will do here, I will use uv rule because there are two functions, so uv. So what is that rule? The uv rule, d by dx of uv is, as we have already studied, it is u dash v plus v dash u. So first the derivative of x, what is the derivative of x? It is 1. Log x is as it is plus, now what is the derivative of log x? It is 1 by x and x as it is. Now this will get cancelled. So what will become dy by dx? Dy by dx is equal to y into 1 plus log x. Now here I will put the y, so this is going to become x to the power x into 1 plus log x. So this is how to find the derivative with the help of logarithm. We can see one or two more examples. Say if y equal to ax, now how to find the derivative? Now here again, since it is in the power of x, in such functions where there are the power x to x or a to x, we use logarithm property. So what is that? Taking log both sides, we get log of y equal to x log a. Always remember the power comes multiplication. So now it's become easy to differentiate. Now here I will write differentiating both sides with respect to x, we get, now what is the derivative of log? It is 1 upon y into, now differentiating y with respect to x. Now here this is constant log a, so here this will, we will keep outside, and what is the derivative of f? This is 1. So what is dy by dx? Now dy by dx becomes y into log a. What is y? Y is a to the power x, so here I can write a to the power x into the log a. This is the answer. So in this way, if there are more functions in additions, we keep the differentiation of individual functions by taking logs, and then we can just add all these functions. So this is the simple way. Similarly, I can take one more examples of exponential functions. Say if there is y equal to 10 root ex. So how I can find the differentiator? So here I have to differentiate with respect to x. Now what I will do here, it is like a composite function. So first I will take the differentiation of 10x. So I will write here d by dx 10 root ex. So this will become sec square root ex. Now what I have to take? I have to take the derivative of root ex. Now again this power comes in picture. So what is the derivative of this? This derivative comes 1 by 2 root ex. This you can easily find if the derivative of root x, it will come 1 upon 2 root x. I can show you here. If it is a function like this, y root x, so what is the derivative? Dy by dx, it comes 1 by 2 root x, because it is nothing but x to the power half. When we do the derivative, this half comes first, then what we do, we subtract this power minus 1. So what this comes? This comes minus half. So this minus half is nothing, we have put into the denominator. So here this is totally x. So here we have write 1 by 2 root ex. Now again we have to take the d by dx of ex. So this will become like this, sec square dot ex into 1 by 2 root ex into e की power x. So this we can write further like this, rearrange 1 by 2, this will become ex into sec square root ex. So here we have seen one example in which there are two functions, composite functions. So here we have derivative this in a simple way. So in exponential functions or logarithmic functions, we can differentiate it by considering all previous formulas and with further new formulas. So this becomes very easy to solve any function. Now let us consider the another type of functions that is known as parametric forms. So how to find the derivative of such functions? Now first we consider what are parametric functions. So parametric functions are those in which there exists a new variable. How you can say? Up to now we have seen the relation between y and x. But if I say some new variable comes in between these two variables and these two are dependent on some another variables, then such type of functions we solve in parametric forms. How? So I can give you a simple example. Suppose if x is equal to a cos t and y is equal to a sin t. Now here you are saying x is varying with the variable t and y is varying again with variable t. Both are dependent on a new variable t. So to find the derivative of such functions, what we do, we take the derivative with respect to t instead with respect to x. So first y equal to a sin t, we differentiate this with respect to t both sides. We get dy by dt equal to a cos t. Now similarly here x equal to a cos t. Again we will differentiate here, differentiate both side with respect to t. We get dx by dt equal to minus a sin t. Now what we have to find? We have to find the dy by dx. So here we can write dy by dx is nothing but dy by dt dot dt by dx. So simply what we have to do here, this will get cancelled. What is dy by dt? Dy by dt is a cos t, and what is dt by dx? Here we have to take the reciprocal. So here I will write in the minus a sin t. So this will get cancelled and this will become minus cot t. Now so this dy by dx becomes minus cot t. Now what is cot t? From this we can see cot t is nothing but, if I divide this by this, so this cot t will become x upon y. So here I can write this. Therefore dy by dx it becomes minus x upon y. Cos t divided by, if I am dividing this, say this is 1, this is 2. Here cos t upon sin t is cot t and this will get cancelled. So x upon y. So in such type of forms we have to differentiate with the new variable t. So this then we can find with cross multiplication like this, and this will become dy by dx. So here in this case also you can consider few more examples and you can do the practice. So in this topic differentiation, here we covered all the various functions and the derivative of all these functions. First, as we start with the basics, we see the derivatives of certain standard functions. Then we see the algebra of derivatives, in which we study sum, difference, product rule, quotient rules. Then we study the chain rules. Then we come on the functions, how to find the derivative of various functions. First we consider composite functions. Then we find the derivative of implicit functions. Then we consider inverse trigonometric functions, exponential and logarithmic functions, and in the last we consider parametric forms. So by studying all this, you have just got an idea how to find the derivative of these functions. But as you will see more problems and you will practice more problems, you can have a confidence, and if you find any problem you can contact me. There is no any such problem. Okay, so this was all about the differentiation. Thanks a lot, and get contact with the Study Khazana.